Welcome to Spring LIB.
All right, so we have the equation for constructive interference, which is d sine theta equals m lambda. So for the blue light, we're going to use the subscript lambda b, wavelength of blue light. And so d sine theta for the second order maximum will be 2 times 480 nanometers, which is the wavelength, and that gives us 960 nanometers. Now, we want this to and so we want this to equal, so d sine theta, then we'll have to equal the equal m plus 1/2 times, or whoops, 1/2 times lambda for destructive interference, which will produce a minimum on the fringe. And so the left-hand side will be 960 nanometers. So this will m plus 1/2 lambda will be 960 nanometers. And let's call this m prime to distinguish the two, to distinguish the order of the minimum and the maximum, minima and the maximum on the screen. So m prime, we're going to try different values of m prime now. Let's start with m prime equals 0. What happens there? In that case, lambda equals 960 nanometers times 2, right? So lambda is 1920 nanometers. Remember, visible light is in the range of around 380 to 740 nanometers, usually quoted to be around 400 to 720 nanometers. That's the range. Okay, so this is above, this is well beyond that range, so this won't do. Let's see, let's try m prime equals 1. In that case, lambda will be 640 nanometers, which is in that range. So this is good. Let's try m prime equals 2. Lambda will be, in this case, 380 nanometers. So it just falls out of that range, or it's just at the edge of that range. This is actually in the far UV. So 640 nanometers is right. So m prime, the order for the minimum will be 1.